Okay, so yeah, as I mentioned, today we'll be talking about WolframScript, which is a command line application in the Wolfram ecosystem that allows you to write Wolfram language code and execute it via the command line. If that doesn't mean anything to you at this point, don't worry, because we'll be covering. We'll start from the very basics. We'll start by talking about what are the differences between the command line and a graphical user interface. Why would we want to use a command line over a graphical user interface? How to do it practically? Obviously, through a lot of the webinar, actually doing um, we'll be doing live um, coding in a sense, or just live execution of code. Um, then we'll cover the basic options in Wolfram script. So how do you evaluate code locally? How do you evaluate code on the cloud? And then we'll kind of finish off with some actual examples that I've prepared before the webinar of simple command line applications written in Wolfram script. So you can get a sense, you can get a taste of the kinds of things you can accomplish using Wolfram script. But let's start at the very beginning, and just in terms of length of the webinar, I don't think it should take more than 1 hour probably. So we'll take a very relaxed pace as we work our way through these discussion points. Cool. So starting with what is Wolfram script. So Wolfram script is the technical definition is a command line script interpreter for Wolfram language. In more practical terms, it allows you to run Wolfram language code directly from your terminal. So it supports several modes of execution locally using your installed Wolfram Mathematica or Wolfram engine, and we'll come to what is the difference between those things a bit later on. It can also execute code in the cloud via Wolfram Cloud or within WSTP server session. Again, something we'll cover later on in the webinar. So with Wolfram script, you can run single expressions. So if you just need a quick answer to something and you know that there's one line of Wolfram language code that will give you the answer, you can execute that directly in your command line interface. If you have a more detailed, longer workflow, you can create a script file, and then Wolfram script can execute that file and produce some result or do something on your computer. And again, when we get to the examples, we'll see what we can use that for. You can also have interactive sessions and even deploy functions and APIs. So deploying APIs is the one thing that we're not going to cover in this webinar because it's a little bit more advanced. But it's good to mention that it is an option. But everything else that you see in this introduction, we will be covering during today's webinars. So some cool things that Wolfram script can do: it can parse command line arguments, it can run Wolfram script files, it can access standard input, and it can integrate with cloud deployment and interactive modes. So just to kind of summarize what the benefit of Wolfram script is, it's an ideal solution that combines the computational richness of Wolfram language with the convenience of small script-based tasks and utilities. So it basically allows you to have access to all of the functionality of Wolfram language without much of the overhead that comes with graphical user interfaces like Mathematica and so on. So in a nutshell, it's another product that allows you to execute Wolfram language code. Okay, so let's say a few words about command line interfaces and graphical user interfaces, because if you're coming in from a point of view where you have used graphical user interfaces for most of your, most of the time when you're working with a computer, you might be wondering, why would we want to strip ourselves back, especially when we have a nice graphical user interface in Mathematica? Why would we want to go back to the command line? So just in terms of basic definition, graphical user interface applications are those that have a graphical point-and-click interface. So in the most basic terms, it's applications that have these windows that you can resize, that you can manipulate on your desktop environment, and they have these menus and buttons that you can click around and do different things with those buttons, with those menus, with those actions. So these types of applications are what you are mostly used to whenever you think of installing an application on your computer. It usually comes with a graphical user interface where the way you interact with the application is event driven, which means that the user interacts with the interface either through clicking a button or scrolling down or right clicking. That generates an event, and then the application responds to that event. So a good example of a graphical user interface application, obviously, is Mathematica. So you have um, you have this nice window. You have all sorts of menus. You have the notebook interface where you can create different cells. You can click around. You can type around, and it's just a normal, nice looking graphical user interface. Yeah, inserting a new cell, evaluating some code, to which Mathematica responds with the expected output. Command line applications, on the other hand, don't have a graphical user interface. So they're still applications in the sense that they are a bundled piece of code that does something, but they are interacted with through commands. And so most commonly passed through a command line interface, such as a terminal emulator or a shell. Command line applications tend to be scripted, although not necessarily. And we'll talk about that when we go to the kind of interactive mode of Wolfram script. But typically, command line applications tend to be scripted, and they take an input and they perform an operation on it. Wolfram script itself is a command line application, and it allows you to create new command line applications using that. And we'll be creating some basic ones today. Just before I go on, someone has a question that they couldn't see the content being shared. Let me just double check if I'm sharing my screen. If you just give me a second, John. I believe I am sharing my screen. At least that's what it indicates to me on big marker, and I do see it on the on YouTube as well. So I believe that might be a problem on your end. If anyone can just quickly confirm in the chat that they are seeing my screen, because that is quite important. Yeah, Randy's saying he can see it fine. So John, if you just refresh the browser tab, that should probably fix it, because people are confirming that they can see it. Thank you for that, for everyone who is confirming. Okay, so okay, let's get into it. Why would we use a command line interface over a graphical user interface? Because it seems like, again, just taking it on a very simple level, it seems like having a nice user interface where we can point things with our mouse and we can click on buttons, that seems like a much nicer way of using an application, any application. So why would we want to use a command line application over that? Well, there are a few categories of reasons why. There are a few things where command line applications have an advantage over graphical user interface applications. The first is obviously they are more lightweight. So having a window with all sorts of buttons and nice visuals is very nice, but it has a computational overhead, especially when we get to kind of more intensive applications that do a lot of computation. And they need to display a lot of outputs, then that can be very taxing on your computer resources. Now, luckily, we live in a day and age where computers are incredibly powerful. So for most use cases and most of the time, we don't really notice exactly how much computation is done under the hood, so to speak. So from the user's point of view, you can launch an application, even though it's a graphical user interface and it does a lot of things. Your computer doesn't really slow down noticeably. But when it comes to applications like Mathematica, where you're manipulating a whole programming language, and you're generating not only text and numbers, but you're generating 3D plots and dynamic manipulating elements, and you can generate whole user interfaces actually through Mathematica. So you can have a graphical user interface application that creates graphical user interface applications. That becomes very heavy computationally. Now, not all of that is a graphical user interface, but actually the front end, what we call the front end, which is the actual window that is being drawn on your screen is actually quite computationally heavy. So if you are running either on an old computer or more more commonly, a more common use case is you're running on a server where um, it either doesn't have a graphical interface at all. So it could be a server you have rented through AWS or Microsoft Azure. It could be your own server that you're hosting in your home. Um, and you want to execute some code on it, but it doesn't have a graphical interface, it's not connected to a monitor. That's where one, you need something that is more lightweight because these machines could be um, weaker. And in that case, more importantly, you need something that is able to do operations, to do tasks, to accomplish workflows without needing a graphical interface. So, going back to the example of if you have a server at home, you want, let's take the most simple example, you want to do some regular backups. You want that those backups to be done every week, let's say. Now, one way to do it would be to, and you can obviously accomplish that with Wolfram language code very easily. In fact, one of our examples is a basic backup example. But you can think you can have a notebook that you can open and then just execute the code, and it just performs the backup, which is all well and good. But you don't, for a task like that, you don't really need a graphical user interface. You don't need to launch a whole front end instance of Mathematica just to accomplish a simple thing as a backup. So in examples like that, it's very useful to have just a command that you can run in the command line, and then the task is accomplished for you. Automated. So that kind of overlaps with the first example that I gave, but in cases where you need things to be automated. So most typically when you need things to be run on a certain schedule. So going back to the backup example, I want my home folder to be backed every Monday at 7 a.m. So I know that if something happens, then the latest backup that I have is no more than 7 days old. Things like that. And for automated tasks like that, command line applications integrate very easily, either by themselves or as part of larger script and pipelines. And obviously, the benefit of that is that they can run unattended in batch mode on remote servers. They can run pretty much on anything. And again, you don't need a graphical interface for that. And they're very easily manageable by your system's job scheduling tools. So because automation is one of the big reasons, one of the big areas where command line applications have an advantage over graphical user interface, we will touch briefly on the job scheduling tools. So, um, as I mentioned, if you have something that you want it to run every Monday of every week, then you need to schedule that task somehow. And we have different ways to do that. You could either do that through native Wolfram language code, or you can rely on your operating system. But we'll cover that a bit later on in the webinar. And then my final category of where command line interface applications are much more convenient is obviously if you're executing code remotely. Again, that could be on a remote server. It could be on a computer at your workplace while you're at home, or vice versa. Just any situation where you're essentially um, controlling a computer that is remote from you. Now, even in those cases, you might start a remote graphical session, and they're very kind of sophisticated ways of doing that, but a much more simple, a much more low overhead option is to just pass a command through a command line interface. And solutions like SSH, if you're familiar with that, are designed exactly with that idea in mind, that you connect to a remote machine securely, and then you pass commands to that machine from pretty much anywhere that you have access to it from. Yeah, this is particularly useful for managing remote servers or cloud instances where graphical user interface access may be limited or unavailable. Again, if it's much easier to have a command line access than a graphical user interface access to a remote machine. And this is where if you have say you have a simple application using Wolfram script, you can just SSH into the remote machine. You can type one command, and then that's it. The application runs and it does its thing. Cool. So there are other reasons why you might want to prefer command line applications, but these are kind of the broad main categories where people do tend to use command line applications um, over graphical user interface applications. And then just in general, they are kind of more minimalistic. So if you think of an application as a way to accomplish something on your computer, how do you do it in the kind of the most minimalistic way? Do you really need a graphical user interface with buttons and all of that? In many cases you do, in many cases you don't. So I think one of the kind of recurring themes that we're going to come across this webinar is that use the right tool for the right job. So if you are developing a presentation where you need to have a dynamic manipulative elements that you want to present to some stakeholders, then you should not use a command line application at all. That's not the right approach. On the other hand, if you're doing a backup on a remote machine that doesn't have a graphical interface, then you should probably use a command line interface. So it's all about and the right tools for the right job. Okay. Next, we're going to have just um, a very brief setup and introduction to what you're going to need to run Wolfram script applications. And just on a more practical level, if you are following along with us during the webinar, what do you need to have installed to be able to follow along exactly step by step with what I'm going to do in the webinar? So the first thing you're going to need is obviously Wolfram script, because that's what we're talking about. As I mentioned, Wolfram script is a tiny application, I believe. Even the latest version of Wolfram script is 5 megabytes. So it's something you can download in a few seconds. If you haven't done that already, I encourage you to do it either now or after the webinar. The link to download it is here, which takes you to the official website, which has a download link. It installs just like any normal application. And once you do that, then you'll be able to use it through the command line interface. Now, the most important thing to mention here is that Wolfram script does not evaluate your Wolfram language code by itself. So the job of Wolfram script is to take commands in the form of Wolfram language code from your command line interface and pass them on to a Wolfram language kernel. Now, your Wolfram Mathematica, if you already have Mathematica, that comes with a kernel. So, and I think this is the most kind of general case, so I'll cover that first. If you're a user that already has Wolfram Mathematica installed on your machine, when you install Wolfram script, it automatically knows, okay, there is a kernel on the machine. We don't need to worry about that. So anything you type, any commands you pass to Wolfram script are going to get delegated to the kernel that is under your Wolfram Mathematica installation. So in the most basic case, if you already have Wolfram Mathematica installed, you can just download Wolfram script and you can use it without any further setup. Everything works automatically. If you don't have any Wolfram products installed on your machine, you will need a Wolfram kernel as well as Wolfram script. Again, the easiest way to get that is by downloading Mathematica, which comes with its own kernel. But you could also download Wolfram Engine, which is simply a Wolfram language kernel that runs on your machine. And the difference between Wolfram Engine and Wolfram Mathematica is that Wolfram Engine does not have a graphical interface. So there's no way to run a notebook through Wolfram Engine, and there's no way to have any visuals. It's simply an application that takes some code, runs it, and gives you back the result. But in the context of Wolfram script will be very happy to pass your code to Wolfram Engine instead of Mathematica, because after all, Wolfram script does not need a graphical user interface. So either Mathematica or Engine will be enough for local running of Wolfram script. And by local, we mean completely local, as in even if you don't have an internet connection, as long as you have one of those two, you'll be able to run your Wolfram script, your Wolfram language code locally on your machine. You could also use a cloud kernel. So that works the same way as if you go to Wolfram Cloud manually and you run some code that is evaluated not on your machine, but it's evaluated on cloud, on a um, Wolfram organization server, not on your machine. And you can use that with Wolfram script as well. So either, but then obviously the disadvantage of that is that the code is not being run on your machine; it's being run elsewhere. So one, you need to have a constant internet connection every time you want to run a code. Which again, if you're just a normal user with a normal machine, you probably already have a constant internet connection, so that's not a problem. But with remote and with different configurations, that may be a problem. So just flagging that. But in any case, the main point here is that Wolfram script is just responsible for interpreting and passing your commands to a Wolfram kernel, and you need to specify where that kernel is. And we'll go through, actually through this webinar, I'll be using a local kernel. I'll be using also a cloud evaluation kernel. So we'll see how we can accomplish um, both of those things. Um, As I mentioned, if you already have Mathematica or if you already have Wolfram Engine installed on your machine, then Wolfram script is going to locate that during its installation, and you don't need to do any additional setup. If for some reason that automatic installation fails, you can locate the configuration file of Wolfram script by running this command, and it basically tells you where the configuration of Wolfram script lives based on your operating system. So if you're running this on Windows, like I am, you'll get something like this, where the configuration is in app data. If you're running this on Mac, that'll be a different directory. Unix, that'll be a different directory. So if you're having trouble with locating a kernel, you can open this file and you can specify where your kernel is by assigning this variable in the file. So all you need to do, let's say I know my kernel is, I don't know, I'll just make up a path here, but let's say program files, Wolfram kernel. Say that's most likely not where the kernel lives, but if this is where your kernel is, or if you have installed Wolfram Mathematica in a custom directory, then your kernel directory will be different. In any case, if Wolfram script is having trouble locating that, just open the configuration file and add a line like that, and then that should be enough to get you started. Cool. So the last thing that we need to discuss is shells. So we are talking about command line interface, and we'll be talking a lot about command line interface a lot in this webinar, but there's not a single universal command line interface. So typically the way we interface with our computer through the command line is through something called a shell. And shells are wonderful. They allow you, as I mentioned, just access to the resources of your machine. You can pass commands and then the machine can do something. But the problem with shells is that there are many different kinds and many different flavors. So when we're talking about command line interfaces and how we are going to use Wolfram script, we inevitably have to do it through a shell. So it's worth spending just a minute or two here kind of describing which shell I'm going to use and how that is going to impact your experience if you use a different shell. So as I mentioned, shells differ based on your operating system. So if you're running Microsoft Windows, you have a different shell than somebody who is running Linux, than somebody who is running a Mac OS. Now, a lot of commands, especially between Linux and Mac OS, they do have very similar shell interfaces. Windows does things its own way, and in the interest of having of making sure that regardless of what operating system you're on, you can follow along with this webinar. I'm going to be using PowerShell, which is one of the options on Windows. First point of confusion is that PowerShell is not the same as PowerShell is not the same as Windows PowerShell. even though they're both developed by Microsoft and they're both official products. Um, I'm going to be using PowerShell just because it has the most overlap with the shell you would use on macOS and most overlap with the shell you're going to use on Linux. So if I use PowerShell now, then Windows users will be able to follow along, and macOS users will be able to follow along, and Linux users will be able to follow along. If I use something like CMD, which is another typical shell that Windows uses, then everything I show you will be kind of specific to CMD, and then we're going to leave all the other operating systems behind. So PowerShell is kind of a nice middle ground between all the different shells. It kind of covers um, not 100% overlapping with macOS and Linux, but in large degrees it does. So how do we actually access PowerShell? Again, I am on Windows, so I'm going to show you how to do it on Windows, and I'll explain how to do it on Mac and Linux. Um, So on Windows, you have an application that comes with Windows 10 and Windows 11. It comes built into the operating system, which is Windows Terminal. I'll launch it here. You can just go to your Start menu and you can type Windows Terminal or just Terminal in this case, and you'll see this little application. Again, as I mentioned, it's built into your operating system, so you'll be able to access it that way. So once we will launch terminal, we'll see this nice little command line interface. And what I'm going to do is I'm going to resize my Mathematica window to go on the left, and we can have our command line interface on the right because we'll be using it a lot in this webinar. So on the left, you'll see my notebook, which is where I'll go through the materials. And on the right, we'll actually be executing the code, and we'll be seeing the results of our command line applications. So once you launch Windows Terminal, you have access to a few different shells. And by clicking this arrow here on the right of the first tab, you'll be able to launch a different tab with a different shell. As I mentioned, I'll be using PowerShell. I think by default, you have access to Command Prompt and Windows PowerShell, which is not the same. I think because of the examples that we'll be using in this webinar are quite simple, there's not going to be a whole lot of difference. So you could probably just use PowerShell or Command Prompt, but I have only tested it on PowerShell. Cool. So then if you are on macOS, then the process is very similar. macOS comes by default with an application called Terminal. So just launch that and you'll see a very similar command line interface. The default shell on macOS is ZSH, which is good enough. You don't need to do any additional setup. And then if you're using Linux, then you're probably very familiar with your command line interface. So just go to that, and that will and you'll be ready to type in your commands. So okay, so we have our terminal emulator, we have our shell, which is in this case PowerShell. I will do some quick tests with CMD and Windows PowerShell as well, just to make sure everything works in those as well. But different people have different preferences for shell. Cool. So now that we have our command line interface open, and I've already installed WolframScript before the webinar, obviously, so that is already set up on my machine. If you haven't, then you would need to do that on your machine. But once you've done that, then you're ready to start using it. Cool. So let's run our first command using WolframScript. So the first thing we're going to, so every time we want to use WolframScript, the command to do that is called WolframScript. So fairly obvious. And then everything that comes after WolframScript is the commands we're passing to WolframScript directly. So in the most simple example, we are passing this -- version command, which instructs WolframScript to print the current version that it's running. So what you're seeing here on the left in my notebook is actually an external language cell. So in Wolfram Mathematica, in the graphical user interface, you are actually able to execute shell commands. But we will be doing that through the command line interface simply because that is how you're going to be using Wolfram script most of the time. Because if you already do have Wolfram Mathematica and you're happy with using a notebook, then you should just use a notebook. Um, we are covering cases where you want to use Wolfram script through the command line. So what I'll be doing through the webinar is I'll be copying the code from these external language cells and I'll be pasting it in my terminal on the right. And that is how we're going to get our outputs. But it's worth mentioning that you can do that through Mathematica itself. So as I mentioned, our first most simple command, Wolfram script dash dash version, it simply prints the version of Wolfram script. So in this case, I'm using 1.13, which I believe is the latest version, and I'm on Microsoft Windows. So currently not doing anything interesting, just making sure that Wolfram script is installed correctly and it can receive my commands. So in this webinar, we'll cover the most common and useful options. As I mentioned, we'll be using a local kernel, so essentially using the same kernel that is powering my Wolfram Mathematica interface. Um, we'll be evaluating with a cloud kernel as well, so a kernel that doesn't live on my machine. We'll be executing code from a local file. We have quite a few scripts, and then we'll talk about the interactive repo mode. So just before I get into the next slide, Andrew is saying the slide says you'll be using Windows PowerShell, but you're actually using PowerShell. Is that right? Let me have a quick look. I apologize if that is correct. We'll be using Windows PowerShell. Yeah. So I got confused because to be honest, I am a bit confused about I'm typically a Mac user, and I found the whole shell situation with Windows a bit confusing. So this is not correct. We'll be using PowerShell, not to be confused with Windows PowerShell. Um, but I mentioned hopefully all of the commands and all the things we'll be doing here will work in Windows PowerShell as well. Let me have a quick look. I'm opening another tab, this time with Windows PowerShell. So if I type Wolfram script dash dash version, that should give me the same output, and it does. Yeah, so you could use Windows PowerShell as well if you want to, but it's just that I have only tested the code with PowerShell just because it seemed to be much closer to macOS and Linux. But yeah, apologies for the confusion. The slide should say PowerShell, not to be confused with Windows PowerShell. That's my bad. Okay, so let's get into executing actual code using Wolfram script. So as I mentioned, every time we use Wolfram script, we'll be calling Wolfram script directly by name, and then everything we pass after that is the command to Wolfram script. So let me copy and paste that into my command line interface, and then we can kind of dissect it, see what's happening here. So again, we're starting with Wolfram script, which tells our shell, pass everything to Wolfram script. Then we have this code option. So the code option is how we execute Wolfram language code. So everything that comes after code is the actual code that we want to be executed. In this case, simple arithmetic 2 plus 2. So Wolfram script sees that. It sees that we want to execute code, and it sees the actual code. So what it does is it takes everything in these kind of single quotation marks, it sends it to the Wolfram language kernel. The kernel does the actual processing and then returns the result. And then our shell prints it out for us to read. So what we've done here, Wolfram script dash code 2 plus 2 is the same as opening a notebook and then doing this. But since Wolfram script simply passes your code to a Wolfram kernel, you can evaluate any piece of Wolfram language code. We can try something a little bit more complicated. More complicated, I mean, in terms of Wolfram language code. The way we call the application remains the same. Just say Wolfram script, execute this code, and then in single quotation marks, just paste your Wolfram language code. So here we're finding the maximum value of some expression, some physics expressions by the look of it. So again, that is the same thing as executing this code in our notebook, which should hopefully give us the same result. So the idea here is that you can take any piece of Wolfram language code and you can pass it to Wolfram script, and you're going to get the same result as if you were running it from a notebook interface. One thing that is worth mentioning here are those single quotation marks, and this is one of the cases where different shells are going to have different behaviors. As someone is already mentioning in the chat, for running code from the terminal, it is not working with the single quotation marks. Instead, I should remove them to work. That is mainly dependent on how shells parse out commands. So if you are using PowerShell or macOS ZSH or Linux SH, then single quotation marks should work. Um, if you're using Windows PowerShell, probably removing them is going to work as well, but I don't think that's going to work on Mac. So the whole idea, the whole problem with shells is, oh, actually, it doesn't work. So the whole problem is that you can have quotation marks in your code itself. So the shell needs to know what is your code, what kind of what delimits your code, and then what is actually the whole command. So if you're using a shell and you find that quotation marks don't work, try removing them, um, and hopefully that should work. But this is one of the things that I couldn't cover every single possible shell and every single operating system slash shell combination. This is something that is going to kind of partly depend on the shell you're using. Again, in PowerShell, and I believe on macOS, hopefully somebody can confirm. Um, Always using quotation marks, single quotation marks, is the best way to wrap your code. So yeah, Heinrich is asking, always using quotation marks. I would say yes. If your code is something as simple as from script code 2 plus 2, then you don't need to use them. But in many cases, you will have quotation marks inside your code. For example, here we're defining the unit of measurement in kelvins, and we need to wrap this in quotation marks. So if we pass this without any opening quotation marks and closing quotation marks, then the shell is going to get confused. It's going to interpret the first part of the expression as one command and then this as another command and so on. So my recommendation, and again, not 100% solid recommendation, but a kind of a safe default is to always wrap your code in single quotation marks, simply because there's not a lot of Wolfram language function that use single quotation marks in their bodies. So again, coming to our quantity example, in Wolfram language, you wouldn't wrap kelvins in single quotation marks. In fact, that's not going to work. And that goes for a lot of Wolfram language functions. So using single quotation marks to wrap your line of code um, is very useful for the shell to avoid confusion. But as someone was mentioning, for them it wasn't working. And when they removed it, it was working. So, you know, that's probably the main difference between using, as far as our webinar is concerned, of course, that's the main difference between using PowerShell versus Windows PowerShell versus CMD and so on. Cool. Okay, so and yeah, we can also pass multi-line code. Um, the safest way, again, to make sure that our shell interprets it correctly, is to finish one line with this semicolon and then start the next line after that semicolon. So here we have a simple piece of Wolfram language code, which let me just copy it in my notebook just so I can show you what it looks like. So we have 2 lines of Wolfram language code, essentially. We can separate them to be clear. We have a module that defines um, it defines some local variable. It assigns a piece of text to that variable. And then on the second line, we are reversing the order of the letters in that variable, and we're getting the results. So if we're working in a notebook, this is how we would do it. We would have 2 lines. If we're passing it in a shell, again, we could pass a new line directly into the shell, but that is going to break some of the shells. Um, so what I would recommend to do is just have them one line separated with a semicolon, and that is going to work. As you can see here, we're getting the same results as our notebook. So this is all about passing code directly into the shell. As you can already see, even though we're using very simple examples, sometimes it's a very brittle way of using Wolfram script. A much more robust and reliable way is using local files, but we'll get to that. I just want to cover this option. Again, this is for the cases where you have a question and you can, off the top of your head, you know the piece of Wolfram language code that you need to write to execute that or to get that answer. So all you need to do is say Wolfram script dash code and then have your code here, execute it, you get your answer, and you move on with your life. Yeah, so here's a tip about the single quotation marks. Again, experiment a little bit with that if it doesn't work for your specific configuration, but it should for most people, I think. Okay, so far we've been using our local kernel, um, essentially the kernel that powers my Wolfram Mathematica. Um, what we can do as well is we can use a cloud kernel. So the way we do that is um, very similarly to using a local kernel, but now we pass an additional option saying dash cloud. Essentially, is telling Wolfram script execute the following piece of code on the cloud and not on my local machine. The first time you run this, you are going to be asked to sign in with your Wolfram credentials. That is just your typical Wolfram ID where you have your email and password. But once you do that, you should be authenticated, and this should work in the same way that it works for me. Um, Someone in the chat was asking that that they're being asked for the Wolfram ID. So yeah, Victor. So you are trying to run the cloud code, so it is normal that you're being asked for your Wolfram ID because Wolfram script needs to know that you are an actual user of Wolfram language. So it's not anyone can just run Wolfram script dash cloud and execute things um, on Wolfram's servers. So yeah, just signing in like you would normally sign into the Wolfram ecosystem should work, and then you get your results. Everything else works pretty much the same. So we can do any piece, I'll say any piece, 90% of Wolfram language code that you run can also be run on the cloud. All you need to do in the context of Wolfram script is add this cloud option, and then everything else should work the same. Again, this is mainly useful if you are running on a machine where you don't have, so you have a license of Wolfram Mathematica, but you don't have Mathematica physically installed on that machine. You can very easily just specify that you want the cloud, the code to be executed on the cloud, and then that is going to work as well. As long as you're a Wolfram user, you can sign in. And also worth mentioning, obviously, you only need to sign in once. Then that information is going to be stored by Wolfram script. Um, Yeah, so but in practical terms, that is very cool because, as we mentioned, Wolfram Script is a 5 MB application. So essentially, you can have a home server, you can install this 5 MB application, and you have access to the whole richness of Wolfram language code, and you can simply evaluate it on the cloud. There's nothing to store on your machine. There's no computational overhead. This can run on very old computers. It can run on headless servers. It can run on Raspberry Pis. You can run on computers that are the size of your palm. It's just a very neat and elegant way of using Wolfram language, I would say. Okay, so we're getting to local files, which again is probably the main way you're going to be using Wolfram script. The immediate benefit is that you don't have to worry about escaping your code or formatting your code in the right way. You can just have a file where you write your Wolfram language code normally, and then you can just point Wolfram script to that file, and then it's much easier. Before I get into that, just someone has a question in the chat. PJ is asking, how is output displayed by Wolfram script if the output would be visually complicated, say a dynamic, a tab view, a table form, and so on? Is it instead given out in input form or so? So that's a very good question, PJ. And I would say if you're using Wolfram script, ideally you want your outputs to be either text or numbers, or you want the functionality, or you want the piece of code to be purely functional. So a code that does something on your machine regardless of the output it gives you. But to answer your question, what happens if you have a code that produces, let's say, a dynamic or tab view or table form? You could ask for the output in input form or full form, but obviously that's not very elegant, and it might not be what you need. Um, Another very common kind of workaround is, let's say your Wolfram script file is producing a table, which is one of your examples. Instead of asking for the output here in your command line interface, you can have your Wolfram script file to save that table into a local CSV file, and then later you can open it with Wolfram Mathematica or with Excel or with whatever you want. And that goes for tables, that goes for images. So instead of requesting, so images is simply not going to work in a command line interface. Um, so if you have a piece of Wolfram language code that produces an image, then the best thing to do is to actually export that image to a local file and then open it um, with a graphical user interface application. So yeah, not ideal, and it is obviously a limitation of all command line interface programs. Um, but there are very simple workarounds. But that's a good question. Um, okay, so let's look at some local files. So far we have been passing our Wolfram language code directly in the command line interface, which works fine for simple pieces of code or a few lines of code at most. But if you're writing anything substantial, then that becomes unwieldy very quickly. What you want to do in that case is you want to create a Wolfram language script file. So just a few words on what is a Wolfram language script file. It's essentially it's a text file that has this WLS extension, and what this text file contains is just simple Wolfram language code. So any code you would write um, in your Mathematica notebook, you can include in a Wolfram language script file, and we'll look at a few of them. Now, one advantage and one very common pattern in using command line interface applications is you are passing you have a functionality that takes an argument, and you'll be passing a value to that argument via the command line interface. So to take a very simple example, um, if we have this pure function here called URL shorten. So URL shorten, if you're not familiar, is a built-in Wolfram language function that takes a URL and it gives you a short version of that URL. Now, in itself, that's already a complete function, and you can pass different arguments to it, and it can give you the result. So here we can try it with archive.org in our graphical user interface just to see how it works. So you pass it any URL as an argument, and then you get a shortened version of it. In this case, it's actually longer because archive is not a very long URL, but you get the idea. So we know how to do that in a notebook. So we simply pass our argument after the function. But how do we do that with a Wolfram script? Um, Wolfram script has its own kind of command line argument parser, which is this $script command line um, global variable. So when that is in a Wolfram script, it is able to parse everything that goes into the command. So when we type, well, actually, let me just use my example here because it's already done. So as I mentioned, we have a few examples of Wolfram language scripts in the notebook materials. So if you have downloaded the notebook materials, you'll see that there is a folder here called examples, and it will contain a few different folders with all the examples that we are going to be looking at during this webinar. So the most simple one is this called URL shortener. Um, so if you open that, you'll see that there's a Wolfram language script file directly in it. So you can open this folder in your terminal, in your shell, and you can copy and paste the following command here, which will do the same thing as, let me make this a bit bigger so you guys can see. So the same way we passed an argument in our notebook with square brackets after the function, when we call Wolfram script, Okay, so actually a few things to talk about here. So let me just not gloss over that. So in previous examples, we had this dash code function, and then we after that we just simply passed our code. When we want to execute the Wolfram script file, we have dash file. So this time we're telling Wolfram script, you're going to be executing code from a file, not directly from the command line interface. So obviously, what goes after file is the name of the file, and then everything after that is an argument to be passed into the arguments of the file. And so in this case, well, let's open our Wolfram script just to see what it's doing. So you can open Wolfram scripts in your Wolfram language, in your Wolfram Mathematica graphical user interface. That's one way that you can write those scripts. But obviously, as I mentioned, they're just text files, so you could also write them um, just in your normal text editor. Um, but for our first example, all we have is the URL shorten function, and we're saying that the argument this takes is the second argument from the script command line. So the first argument is always going to be Wolfram, the whole command that is being passed by itself. The second argument is going to be everything that comes after the file. So in this case, this so this is the command. This is the full command, which will be the first argument. The second argument is the actual um, argument that we're passing. You'll see here again, I've wrapped this in quotation marks. Always a good idea when you're passing arguments, but it shouldn't be a problem even without them. Um, but yeah, the second argument is this archive org directly, and we can have multiple arguments. Obviously, here we can have something else like google.com, and the way we can access that google.com via the command line is if we have script command line take argument number 3 and so on and so forth. But in this case, we're only passing a single argument, so we are just looking for number 2, which is the first argument that we're parsing. And we can run our script, and it does what it's supposed to do. Now, you'll notice that we are not getting any output. So we are running this command. It seems to take a few seconds, but we are not getting any output. And the reason for that is when we use Wolfram script with the file option, it executes all the Wolfram language code in the file, but it doesn't print any output. Again, very useful if this is an automated command and you don't care about the output. But for most of the examples in this webinar, we actually want to see the output, and we can instruct Wolfram script to actually print the output back to us. So let me copy this and show you what it looks like. Okay, so this is the command we're running now, identical to the previous one, except we have added one more option, which says print, and that obviously does what it says on the tin. It executes the Wolfram language code inside the file, but also prints the output. So here we get the shortened URL, and again, just to show you that this works, when we open it in a browser, we see that the URL shorten function has worked successfully. So if you want to see the output, just pass this additional print command to your Wolfram script, and then you'll see the output. If you have something that's automated, you don't need to say print, you don't care about the output. Just skip that, and then Wolfram script will just happily execute whatever is in the file without printing anything out. Cool. The last thing we want to talk about before we move on to our actual example. So far we've just been talking about all the functionality inside Wolfram script. So how to use it with local kernels, how to use it with cloud kernels, and so on. I do have a few examples of just some Wolfram scripts that I've written, but before we get into that, the last kind of way of using Wolfram script that I want to cover is this kind of interactive mode, or what's known as REPL mode. REPL stands for read, eval, print loop, and you'll see why when I run this. So if we want an interactive mode, we simply call Wolfram script without passing anything, without saying file, without saying code, without saying print. Just type Wolfram script and you're going to get this nice interactive mode, which you can think of it as a notebook in your command line, but a notebook where you can only edit one cell at a time. So when you run just Wolfram script by itself, you get this input field, and you can, again, you can type your Wolfram language code and you get an output cell. Again, very similar idea to a notebook. You can assign variables, of course, um, and then you can reference them and you get their outputs. So same idea as a notebook, but obviously much more limited because I couldn't just go back to the first cell now and change it. It's already there. So if I want to clear something, I'll need to type clear all A, and then hopefully A is not going to be defined. But um, the idea is you get a, instead of passing code directly through the command line, you get this kind of interactive um, dynamic interface that is notebook-like, but obviously much more limited. But you can do, again, for quick things that you want to write a few lines of Wolfram language code, just launch Wolfram script and just type your code and it's going to work. Once you're done with it, you can type quit, which closes the interactive session, and you're done. So again, a very situational use case, but worth mentioning. Cool. Okay, so before we get into the actual examples, just a few words on automation. As I mentioned, you could use, there are functions in Wolfram language that allow you to automate the execution of Wolfram language code. The most kind of relevant for this case is local submit. And local submit takes, well, it takes a Wolfram language code as an argument, and then it runs that Wolfram language code at any intervals you specify. So you can pass something to be run every day at 9 a.m., for example. And that's a very simple to use. If you're familiar with Wolfram language, you'll be able to get it immediately. Obviously, the disadvantage of that is that in order to do that, Wolfram language needs to keep a Wolfram language kernel running on your system all the time. So instead, typically what you're going to do is you're going to use, every operating system has its own automation tools or own kind of task scheduling tools. So you typically use those, but you're very free to use the built-in functions in Wolfram language if that is more convenient for you. But just to mention, for the different operating systems, so if you're on Windows, you have a task scheduler application, which is actually quite nice. I've played around with it a little bit, even though I'm not a Windows user. But it basically allows you to specify a command to be run again at regular intervals on different conditions and so on. And it has a very low performance cost because it's already built into your operating system. So why is that relevant to us? Typically, when you write a Wolfram language script and you want it to be executed on a regular interval, you can use task scheduler on Windows to do that, or cron for Linux, a very common command line tool actually for doing the same thing, and cron or launchd on macOS. So if you're interested in automating your Wolfram scripts, I would recommend starting from here, or if you don't care about a Wolfram language kernel running on your system all the time, then just use the built-in functions in Wolfram language like local submit. They all allow you to do the same thing. You have a piece of functionality, you want it to run at regular intervals, they allow you to do that. So that's all that this is about. Cool. Finally, examples. So as I mentioned, nothing crazily complicated, but just a few things to kind of give you an idea of what you can use Wolfram script for. The first example that we have is planets observability for tonight. So I think for each of the examples, I will actually open the Wolfram script before we execute it, just to see what the Wolfram language code looks like. And then we'll execute it through our command line interface just to see what the output there looks like. So let's start with the first example, planets observability. So if I go to the notebook materials, it should be under planets. So the Wolfram script is here. We can open it with our Wolfram Mathematica. just to inspect the code. And again, you don't have to open with Wolfram Mathematica. You can open with VS Code or any text editor you like, because this is just a simple text file. Whereas notebooks are typically, even though notebooks are text files themselves, they have a lot of metadata. So if you open a notebook in a text editor, you will see that most of the things are kind of metadata that you don't actually see in the notebook. Wolfram language script files are purely text files. There is no metadata in them. So everything you see, so if you open this file in VS Code, you're going to see exactly the same thing as if you open it in Mathematica. So what are we looking here? So we're looking at, again, not awfully complicated, about 50, 60 lines of code. Piece of Wolfram language function or a few functions. And what this piece of Wolfram language script does is it looks at your location. So in this case, I have hard coded it to my own location. If you want to use this for yourself, you can input your own coordinates. Um, but it looks at your location and it looks for, it uses the built-in astronomical data in Wolfram language to tell you which planets are going to be visible in the night sky tonight based on your location. So if you run this with a geoposition of this would be Oxford in the UK, where our European offices are based, you'll get a different result than if you substitute that with your own location. So takes location, takes a time zone, um, looks at all the different planets. It mainly uses this astrorise set function, which is a built-in function in Wolfram language, which provides a lot of information about astronomical objects, such as planets. In this case, we're mainly interested in when does the astronomical object rise and when it sets, based on location and time. And there's some more functions here for structuring the output and for making it nice. Um, and presentable and so on. But a very basic piece of Wolfram language script that uses built-in functionality to get some information, basically. So let's see what that looks like once we have the script already written and saved. Let's see what that looks like when we call it from our command line. Here I am using this copy to clipboard, so I am building up the command line functions in Wolfram language so that, again, if you're following with us, you can just evaluate the cell and it's going to give you the right path for your computer, because that's not going to be the same as mine. Mine is in users, my name, downloads. So if you evaluate this command, you'll get the right path for your use case. You can just paste it in your command line interface. So the first thing we're doing is we are navigating to our to the folder where our example lives. Again, so cd is probably going to be a command that is specific to PowerShell. I'm not sure if let me just do a very quick test with Windows PowerShell. Okay, that works on Windows PowerShell as well. It definitely works on Mac, definitely works on Linux, and it seems to work on the Windows shells as well. But cd stands for change directory. It just lets you navigate the directories in your machine. So once we have navigated to the right directory, we can use our now familiar command, which is wolframscript print, because we want to see the output, file because we want to instruct wolframscript to execute code from a file, not from the command line directly, and then the name of the file that contains our code. So let's do that, and let's give it a few seconds, and let's see what our output looks like. Okay, so we have an introductory sentence, which is the first thing in the output. The sun sets at 5:06 p.m. today. After the sun sets, 7 of the planets in our solar system will be observable. And then for each one, we have the interval in which it will be observable. Um, so yeah, there's a bit of styling to make the planets have different colors. But it's a very basic set of Wolfram language functionality. Everything is built into the language, so you can just query that information and then you can present it in a structured way. If there is an interval in which all 7 planets are visible, then that will be printed here. If there is no interval, currently there's a kind of a nonsensical output here, infinite future and infinite past, because there is no interval. So Wolfram language has to print something. I can work on the Wolfram script to kind of handle that edge case, but I think when I was developing this example, it always used to be an interval, or on the specific day I was developing it, there seemed to be an interval when all of them were observable. So this said something like between 2 a.m. and 3 a.m. all planets will be observable. That's a detail of the code itself and has nothing to do with our Wolfram script. But you can see that for something that has a nice text output, it works very well as a command line tool that you can call again from anywhere. So I'm calling it on my local machine, but if I was on a different machine and I could SSH or access this machine remotely, I can run this exact same command and I can receive this exact same output, even though I don't have any Wolfram products on the machine that I'm remoting from. Cool. Just a few more examples that we can go through. So let's clear the output of this one. Backup script. So as I mentioned, a very common use of command line applications is backups. So here we're going to show, or again, let me show the code first before I execute it. So this would be in backup. Can open it. So this is a much more simple piece of code. It is looking for the original data or what is going to be backed up, and it's looking for a folder called examples in the current working directory. And is we're also defining destination. So where is the example folder going to be backed up to? And it's going to be backed up in a folder called examples backup. And then we're running this copy directory function. Let me make this a bit bigger. Then we're running this copy directory function, again, built-in function in Wolfram language that takes a source and destination and it makes a copy. Very, very simple, basic stuff, but let's run through it because this is something that is perfect for automation. But let's run it first. So again, first we're navigating to the appropriate directory. Again, if you evaluate this piece of code, then this will point you to the right directory without you having to do that manually. And then we are executing our standard Wolfram script -file, and then we're pointing to the file. And what that's going to do is exactly what it says. It's going to take the examples folder and it's going to copy it to the same directory to a different folder. So let's see if it has done that. So you can see in my webinar materials now I have examples and examples backup. So obviously in real life you wouldn't back up to the same directory. You would back up to an external drive or a different location at least. But that is something that once you set up, and it could be a very, as you saw, it could be a 3-line Wolfram script file. Once you verify that it's working, it's a perfect candidate for automation. Just open up Task Scheduler on your Windows machine and say, I want this to execute every Monday. I want to back up a specific folder that's very important to me, and I want to back it up to this external location just to make sure, for my peace of mind, that I always have a backup there. Very simple example, but could be useful as well. A slightly more complicated one in this case. So the next example is about producing a personal portfolio report. So Wolfram language comes back with many finance-related functions. So we could define our whole portfolio in Wolfram language, and then once we have done that, we can perform different computations on it. So in this case, I am going to define a portfolio using Wolfram's built-in functions. So there's a lot of built-in financial information about companies. As far as this example is concerned, we can query their current price, their current stock price. So if I say that if I define a portfolio and I have 20 call options from NVIDIA, I can use Wolfram language to get the current value of my portfolio by checking the price of NVIDIA stocks today. So all this piece of code here is it generates a random portfolio, random-ish portfolio, using a few random choices from these well-known companies, Apple, Tesla, NVIDIA, and so on. Obviously, if I had a real portfolio, I would use that, but I don't, so I have to make one up. Everything else is pretty much just making sure that the portfolio is generated and any errors are handled and so on. So every time you run this little function here is going to generate a different random portfolio. So in this case, it's generated, yeah, just I have shares in Alphabet, 14 shares uh, to be precise, Amazon, Apple, Tesla, and so on. Once I have this Wolfram language object, I can put it in my cloud. Um, and to upload a Wolfram language object to the cloud, you can simply use the cloud put function. Um, they'll pass on the actual object that you want to upload to the cloud, give it a name and permissions. Obviously, if you're uploading a financial portfolio, please make sure that permissions are private. That makes sure that even though it lives on Wolfram servers, nobody can access that portfolio other than you. Here, because I'm just using a random portfolio and I need it for the example, I'll make the permissions public. Um, but once we have a portfolio on the cloud, we can use a few different Wolfram language functions. The most powerful of which is financial derivative, which can uses the built-in financial data and the built-in computation in Wolfram language to provide you with some values related to your portfolio. Um, so in this case, what we're going to do is we're going to use mainly financial derivative, a few other functions as well, to take this random portfolio that we generated and to do some analysis on it. So again, let me start with showing you what the code looks like. Why did I close this? Go to Wolfram script. So the current example lives in the finance folder. Um, so let's open it up and have a quick look at it. So again, slightly more complicated function, but really what all we are going to do with this function is take the portfolio and then analyze each of the options in the portfolio using the built-in functions in Wolfram language, and then produce a nice looking report. So let's do that. Again, I'm not going line by line through the code just because that while the idea is very simple, there's a lot of, for example, text processing to make sure that the output looks nice, and it's really not worth spending the time here going line by line through it. If you're interested in the code, obviously you have access to all the materials. I do invite you to look at it. But really, in the context of the webinar, we're mostly interested in the output. So let's run this Wolfram script and see what our output looks like. So it's going to get some data that is related to our financial instruments, obviously data about the current price and so on. And we get a nice portfolio summary that tells us the total value. So again, we have our random portfolio here, but we don't know the value. So the value of my portfolio today is $605, so I'm doing quite well. And then there's breakdown by the different positions. So my Google options are valued at this much, Amazon at this much, Apple at this much, Tesla, and so on. So again, a lot of the code that you saw in the Wolfram script is just about printing this in kind of a human readable way. And then another thing that this does is it generates a text file that it prints in the current working directory. So not only do you get the output of your portfolio summary in the command line, you also get a nice report here in a text file, and then you can use that for whatever you want. You can send it to people, you can send it to yourself, you can modify it, you can do anything you like. But again, not so much about the portfolio itself, but this example gives you an idea of things that are time sensitive, because obviously the value of my portfolio is this today, but if the price of any of the stocks change tomorrow, then that's going to be a different thing. So that's the type of thing you want to be running at regular intervals. And then you might also want to produce local reports as well. So it's a simple text file, but it could be an Excel spreadsheet, uh, it could be a visualization. So instead of outputting a text file, you might output an image, a list line plot, whatever you have. since you're in Wolfram language, essentially you have access to all sorts of different things. Um, Oh yeah, Heinrich is asking, can you put this info in a spreadsheet? Absolutely. So I should have done that in the example because it makes more sense to put it in a spreadsheet rather than a TXT file. But yeah, since you're doing basically anything you can do in a Wolfram language notebook, you can do in Wolfram script as well. The only limitation you have is whereas if you do this in a notebook, you can visualize the spreadsheet immediately without leaving Wolfram Mathematica. Whereas if you're doing it in a Wolfram script, you have to output it to a CSV file, and then you have to read that or whatever file you want, and then you have to read that file. But other than that, other than output modalities, then you can do the same thing. Um, let's see. We have again slightly more complicated example. This is actually quite fun. So let me open the source file, and we can talk about what the example is doing. So the next one is in a folder called news, and we can open the Wolfram script so we can look at it. So I'll give you the basic idea of what this is doing. So this is when you run this piece of Wolfram script code, it goes to the front page of the BBC, BBC being the main state news site in the UK. It goes to the front page. It looks at all the news that have been published today on the front page. It downloads the texts from them, and it creates a semantic search index. So just a few words on what semantic search index means. Semantic search index is a very accessible way of providing context to AIs. So we're using it here because if we use, let's say we use OpenAI, we use ChatGPT, then normally it wouldn't have access to information from today. There's a information cutoff point, usually a few months in the past, sometimes a year in the past, and whereas it has ingested everything before that cutoff point, it doesn't have up-to-date information. So the way that AI providers like OpenAI go around this problem is that they allow their AIs to search the web. So if you ask, again, taking the ChatGPT example, if you ask what has happened today in America, it's going to search in the internet, then ingest that information, and then answer your question. And that's fine for public information, and that's fine if you have an internet connection. But what if you want to use AI for information that is not public? So it could be your private information, it could be private information of your company, anything basically that the AI couldn't just search on the web for and get. Um, the way that I would say the easiest way probably um, to provide that information to the AI is to create a semantic search index. So that creates, you can think of it as a encyclopedia of new information that you can pass to the AI. And it then has access to. So if you ask it questions related to that information, it can answer them. In this case, we are using it for public information because I wouldn't use. Oh, it's a public webinar. That's why. And but what we are doing is we are getting all of the articles from the BBC front page, and we're creating a semantic search index based on them, and we are providing that to our LLM. Basically, what that means is that we can ask any questions related to today's news, and then the AI is going to have the relevant context to answer those questions. So all of that is that's really all the example is doing. So I can show you what that looks like when we run it. Uh, so again, let me clear the output here. One thing to mention, wow, this is running because this is going to take about a minute to run, I think. One thing to mention is that to use that, because this example uses AI, this is the only example in the webinar that you wouldn't be able to run outside the box. You need some link to AI from your Wolfram Mathematica installation. That could be through LLM Kit, which is our built-in service for AI, or it could be through external providers like OpenAI or Anthropic or any of the external providers. There are different ways you can link your own API keys from those providers to your Wolfram installation. Or more recently, we also support local models. So you can run a local model on your machine and you can link that to your Wolfram language installation. And that way you wouldn't need to pay anyone for AI access. Well, you need to pay your electricity bill, but other than that, there are a few different ways you can use. You can link AI to your Wolfram language installation, and you need to have at least one of them for this example to work. So I should have probably mentioned that at the beginning, but again, this is the only example that's using something extra. Um, so let me show you what I have done. So there's quite a bit of output here, and most of it was just building the semantic search index, like status messages and so on. So here, what I did, I'm going to highlight the command. So Wolfram script, we're printing the output. We are saying we will be executing from a file. So this dash F is the same as dash file. It's just a shorthand. It's just a quicker way to say file. Then we're specifying where our file lives. And then we have an argument that we're passing down to the Wolfram script. And in this case, it's what's been happening in the world recently. And because we are providing a semantic search index, when the AI is answering this question, it's going to look at the information that we have provided it and then answer based on that. So going to the output now, most of the things you see are status messages. So when a semantic search index is being built, you have a nice status message because it could take a long time if you have a lot of data. So we can ignore that. We are connecting to our AI provider. In this case, I'm using Wolfram LLM service. If you're using something else, you're going to see status messages related to that. If you want in your Wolfram script, you can kind of suppress all of these messages so you don't get them. But it's very useful for development to see what's happening. And then our actual output, the thing we care about, is here at the bottom, which is the AI answering the question based on its information. So recently, there's been a significant attention on China's overseas investment, blah, 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 blah. So it has looked at whatever is currently on the BBC front page for today, and it has determined that this is the best answer to our question. So this is a different example in the sense that this is not really something you would run on a regular schedule, but it is something that you only really need text output. So it is another type of thing you could do with Wolfram script. And the scraping code for the BBC is already in the Wolfram script file. So if you run this code, as long as you have an AI provider, this is going to work for you out of the box in that sense. Cool. And I have one more example. I believe this is the last one that I want to show you. And this is generating a summary of key information from an SQL database. Again, maybe just worth having a quick word on what SQL databases are, just so that the example makes sense. So SQL databases are relational databases that are widely used in organizations to store huge amounts of data in a very kind of efficient way. So and in a way that allows very efficient lookups. So you could have gigabytes and even terabytes of information in a relational database, and you can search for some information. You can get it within milliseconds. So very powerful technology that is basically underpinning the database storage of all large organizations. The only drawback with SQL databases is that you have to write SQL code, which is a formal programming language. So what we're going to do here is we're going to hard code the SQL queries in a Wolfram script, and then we'll just use it from the command line. The main advantage of this example, what this example is trying to get across, is that you can essentially write Wolfram scripts for other people. So maybe you know how to write SQL code, you write it in a Wolfram script, then anyone you share it with can use this to, in this case, query an SQL database. Let me show you. So the example we're using here is a made-up example. It's a simple SQL database with a few tables. So we are imagining that we are a publishing company and we have a database that stores our business logic. So we have a book inventory, books, authors, royalties, sales, just a kind of a simplified version of what a real publishing database might look like. Then we're going to populate it with some fake data. So we're going to have some authors who have written some books and we've sold a bunch of them. And then we're going to query that using Wolfram script. So the first few lines of code here are simply creating the database and populating it with fake sales. And again, Wolfram Language has an interface to relational databases, so you could do quite a bit of it, uh, quite a bit of operations in relation to relational databases directly from Wolfram Language. Um, and then once we have done that, once we have created our database and populated it, we can execute our Wolfram script, which before I do, again, I'll show you what the code looks like. So this example lives in database and summary. So let me open that. So here we are creating a reference to our database and we are running some commands. So we are executing this piece of SQL code through our Wolfram language interface, and we are producing a report. Much like our financial example, we're producing a report and we're printing that. And the thing that is different in this example is that instead of saving it to a local text file, we are sending it by email. In this case, I'm sending it by email to myself, but if you were using this, you could send it to anyone you want. So let me run that example, show you what the output looks like. So again, I'm simply navigating to the right directory that contains my code, and I'm running Wolfram script file and just passing the name to the file. So this is telling me, so when I use the send mail function, as you saw, I had a very simple one-line command, which by default sends an email to your Wolfram ID. So if you use it, you're just sending an email to yourself. You can pass an association with it, and then you can send it to other people. This is basically telling me that I haven't configured anything, so it's just going to try its best to send me an email, which hopefully should work. It does, so I can show you what the email looks like. Just give me a second to bring it to the right monitor. So again, a very basic rudimentary email that is saying, last week we generated $1,000 in revenue. These are the top 5 selling books. Thank you all for your hard work. So you can imagine this is an email that goes out to your team, again, as a scheduled task on a weekly basis. Um, and again, all of that is made up data, but it is an actual SQL database. So if you do have an SQL database at your organization, um, you can use Wolfram script to read information from it and produce these nice, well, I won't call this a nice looking email, but you could make it nice if you want to. This is just to give you kind of a flavor of the things you can do. And that is, I think that is it for this example and pretty much for the webinar. There are some other uses. Hopefully the examples gave you a few different ideas of things you could use Wolfram script for. If you are interested in more, you can read the slide in the notebook, but pretty much anything that you need a text output, or you need to run as a scheduled task, or you need to produce some report on a regular basis, that's really where Wolfram script shines. Some tips that may or may not be relevant to you, depending, some are depending on the shell, some are depending on the output, and so on. So this has been it. So just a few words to say in conclusion before I see I have a few questions in the chat, so I'll answer those. But Wolfram script's a powerful tool, extends the capabilities of Wolfram language beyond the traditional notebook interface, enabling automation, scripting, and integration with other systems. Mainly used for automating data tasks, but could be used for processing data, creating applications. It offers a flexible environment for executing Wolfram language code seamlessly across various platforms. Again, you're able to execute Wolfram language code locally, in the cloud, from a remote kernel, and so on. We went through a few examples. That's basically the types of things you would use Wolfram script for. Hopefully they gave you some ideas of what you could use it for. If you have any questions, please feel free to put them in the chat. I'll go through them now before I head off. But that's been it for today's webinar. Hopefully it was interesting to you. Thank you all for attending. If you are, we have another webinar tomorrow. If you're interested in parallel programming in Wolfram language, please sign up for tomorrow's webinar. One of my colleagues will be delivering that, another really good webinar. And but that's been it for me for today. I'll answer some questions. If you do have questions, put them in. If not, thank you for your attention. I hope to see you in the next one.